You are welcome to online lectures with Pharmaceutical the Schoolboy. Today we are going to take a look at pharmaceutical calculations, and the topic is dilutions. This is a kind of revision class, the kind of question-oriented lecture where we would solve as many questions as possible. Then if there is any need for explanation, then we'll do that. So I will start from question number 1. There's a question here. It says, okay, the question says, a product consists of a solid vehicle. 2 grams of the solid ingredient is contained in 500 grams of products. A further 250 grams of vehicle is added to the products. Find the concentration of the diluted mixture as 1. Percentage strength, 2. Ratio strength, 3. Amount strength. Okay, now let's go back to the question. Solution. To solve this question, we need to understand something. To be able to solve this question, we need to understand something. That the product itself has the amount of the product itself is 500 grams. And inside that 500 grams, the ingredients is 2 grams. The active ingredient is 2 grams, and the solid inside a product that has weight of 500 grams. Now, extra 250 grams of the vehicle was later added So they want us to now find the concentration. For us to be able to do this, we now need to understand first that the concentration of the initial product that has 2 grams in 500 grams is simply 2 grams of the active ingredient in what? 500 grams of the what? The entire what? Product. 2 grams in 500 grams of the what? Entire product. But at the end, 250 grams of the vehicle was added. Inside this 500 grams is 2 grams more. So that means if you want to know the amount of the vehicle, you subtract 2 grams from 500 grams, you get the amount of the word vehicle, because they are both solid. Now, but 250 grams of the vehicle was added extra. So, see what was added was something like this, over 250 what? Gram. Extra 250 grams of the what? The vehicle was what? Added. But no active ingredient was added. So if this is 0 gram, no active ingredient was added. Over, remember that this is just the vehicle alone. So that means the vehicle plus zero active ingredients. This is what 2 grams in 500 grams was there before. Then 0 grams in 250 grams was also added. So if you now want to find out the final concentration, we add up, but we will not add it as our normal fraction. We add the numerators separately, add the denominator separately, and get our concentration. Let's go. So this is certain as saying this 2 grams plus 0 grams is what? 2 grams. In 500 grams plus 250 grams plus 0 grams is 750 grams. So over what? 750 what? Grams. So the diluted product now has 2 grams of the active ingredient in 750 grams of the products. Because it now says we should find the percentage what? Strength. Now let's solve it here. So this, if we separate this now, this is certain as saying, okay, let me complete it. This is certain as saying 2 grams in what? 750 what? Grams. That's the meaning. So if we have 2 grams in what? 750 grams. The question saying we should find a percentage. Percentage mean per 100. So how many will we find in 100 grams? That's the meaning. So we don't know, we call it X. So X we found in what? 100 grams. So let's find X. If we cross multiply, X will now become what? X will now become what? 2 grams times 100 grams over what? 750 grams. So X is equal to, great gram will cancel this gram. We have 200 divided by what? 750. We have what? 200 divided by what? 750. So we don't waste our time. We simply do so 0.2662, probably 0.27. 0.27 gram in what? 100 grams. So if we have 2 grams of the active ingredient and 750 grams of the what? Product, how many grams would we find in 100 grams of the product? We simply multiply. So we have 2.27 grams will be in what? 100 grams. So if you now want to put it in percentage, in the percentage notation, it becomes that the percentage strength is now equal to what? 0.27%. This weight, this gram and gram will turn to what? Weight in what? Weight. So the percentage strength is what? 0.27% weight in weight. Now, number 2 says the ratio strength. Ratio strength. Ratio strength is expressed in this form. Ratio strength is expressed in this form. 1 in what? R. So what it means is that, which is something as saying 1 over what? R. What it means is that we are going to reduce this numerator until it becomes what? 1. So we have to work on this, make this to be 1 over whatever we get at the what? End, at the end of it. So whatever we get at the end of it, we now express it in this form. 1 in R. R is the one, the denominator. 1 is the what? The numerator. Then this gram and gram will turn to what? Weight in what? Weight. Weight in weight. Now, in another way now, we can simply say we look for the equivalent ratio or fraction of this such that the numerator is 1. Simple. So let's go. What it means is that we divide, for us to make this to be 1, we divide both the numerator and the denominator by 2, because 2 divided by 2 is 1 gram. Then 750 divided by 2 is 375 grams. So we have something like this. So if we divide both the numerator and the denominator by 2, we have something like this. We have something like this. 2 grams over 2 all over 750 grams over what? 2, which is, this divided is 1 gram over what? 750 divided by 2 is 375 what? Grams. So we have 1 gram in what? 375 grams. So this gram will turn to what? Weight in weight. You now have that the percentage, that the ratio strength is now 1 in 375 weight in what? Weight. This is the what? The ratio strength. Okay. Number 3 question says that we should find the what? The amount strength. That we should find the what? The amount strength. We should find the what? The amount strength. Okay, let's go. To find the amount strength, we simply start from here. We only have 2 grams in what? 750 what? Gram. We really have what? 2 grams in what? 750 grams. So we simply divide through. We simply divide through and find the decimal fraction then. And if you divide, if you divide through, we have something like this. 2 divided by 750. We have 0.0027. We have what? 0.0027 gram per gram. 0.0027. But sometimes you may see when you have something like this, because it looks somehow, this one, because also because it's smaller to compare with this one, sometimes you see this one being converted to what? Being converted to milligram, something like that. You may have something like this. If you move it to milligram, remember that one gram is what? 1,000 milligram. So that means 2 grams will now become what? 2,000 milligram. So if we substitute 2,000 milligram for 2 grams here, we have that 2,000 milligram over 750 grams is equal to, if you divide 2, we have roughly 27 or 2.7. Let me see. This we have is 2.7. We have roughly 2.7 milligram per gram. 2.7 milligram per gram. So this, but I prefer living in this form. 2.7 milligram per gram. So that is the what? That's the answer. Okay, excuse me. Okay, I will give like 1 minute or two. Let me say 2 minutes. If you have any question, feel free to ask so we can continue. Just 2 minutes for questions. For questions, you can call this line 081 38 68 2003 or 070 12 94 5891. You can place your call so I can give you the answer you are looking for. If you have any question, any confusion, or anything you don't understand in any of the steps I took here, please feel free to call the numbers I listed, I wrote on the board. So we have 2 minutes more. Okay, let's go over to the next question. Let's go over to the next question. Okay, let's look at this question. It says 100 ml of a 1 in 50 weight in volume solution is diluted to 1000 ml. Full stop. Find the concentration of the diluted product as a 1. Percentage strength. 2. Ratio strength. 3. Amount strength. 100 ml of a 1 in 50 weight in volume solution is diluted to 1000 ml. Full stop. Find the concentration of the diluted product as a 1. Percentage strength. 2. Ratio strength. 3. Amount strength. Now let's go. Solution. Okay. The initial solution, the stock solution, the volume is 100 ml and the concentration is 1 in 50 weight in volume. This is the ratio strength. By virtue of this saying this weight in volume, it's clear that the active ingredient is a solid, while the entire product is a what? Liquid. So there's a solute. There's a solute is solid. Then in the vehicle is what? Liquid. Now from here, now this 100 ml of this solution that has this volume, this 100 ml of this concentration was diluted to 1000 ml. Now we are now asked to find what? The concentration of the diluted what? Products. The concentration of the what? Diluted what? Products. So without wasting time here, I can solve this thing straight without wasting time using the dilution formula. Here we have, we say that C1 V1 is equal to what? C2 V2. So here, the C1 here is the concentration of this stock solution, while V1 is the volume of the what? Stock solution. Then C2 is the concentration of the diluted solution, while V2 is the volume of the what? Diluted solution. That's the volume it was diluted to. We know C1 here, we know V1 here, we know V2, but we don't know C2. So we're looking for what? C2. So C2 is equal to what? C1 V1 over what? Over what? V2. So from here now, our C1 is equal to 1 in what? 50 weight in volume. 1 in 50 weight in volume. For us to be able to work with this, let's move it to percentage strength so we can work with it. This 1 in 50 weight in volume means, remember the convention, unlike the one we solved previously when we have weight in weight. If we have weight in weight and we have something like this, the weights must not be in a particular weight unit. They can be in milligrams, but the most important thing is that they should be the same thing. They should be sensitive before you can cancel, before you can divide. But here now, in this case now, when we have a solid, a liquid, weight in volume, then it changes. Here, the weight must be in gram, while the volume must be in what? Mil. It's compulsory that the weight must be in gram and the volume must be in what? Mil, before you can expand this, move it to percentage. Now, by what this thing actually means now is that we have 1 gram. 1 gram. Let me write it well. What this now means is that we have, this implies that we have 1 gram of the solute or the active ingredient in what? 50 ml of the what? Solution. That's the meaning. So if we have 1 gram in 50 ml, remember the percentage. We are moving this to percentage, so we can work with it. If we have 1 gram in 50 ml, percentage is in per 100, in 100 ml, percent per 100. So how much of this solute can we have in what? 100 ml. Now, so we now look for it in 100 ml. So we have x gram will now be in what? 100 ml. Let's find this x. If you cross multiply, x is now equal to what? X is now equal to what? 1 gram times what? 100 ml over what? 50 ml. So if you divide 2, this divide is ml, of course we cancel ml. 50 divided 100 is 2. So we have 2 gram. So there will be 2 gram in what? 100 ml. So if we have 2 gram, I'm not sure that this is clear. I think let me solve this thing here. Sorry. Let me come up here so we can see it clearly. I'm not sure you can see the board there. So let's solve it here. So if you have 1 gram in what? If we have 1 gram in 50 ml, so how many do we have in what? 100 ml. So that means x will now become 1 gram times 100 ml over what? 50 ml. Here ml will cancel ml. This 50 divide 100, we have 2. 2 times 1 gram is what? 2 gram. So basically we now have 2 gram of the solute or active ingredient in what? 100 ml solution. So if we move this to percentage, now we have 2 in 100 is 2%. 2%. So we have 2%. This gram we change to weight. So we have weight, and this ml we change to what? Volume. So we have 2% weight in volume. So the percentage strength. The percentage strength of this is now 2% what? Weight in volume. Now we have moved our C1 to what? Percentage strength. But our V1 is what? Our V1, let me come here. Our V1 is what? From this question, our V1 is what? Our V1 is 100 ml, yes. So C1 is what? 2% weight in volume. Our V1 is 100 ml. Our C2 is what we are looking for, we don't know. Then our V2 is what? 1000 ml. So using this dilution formula, C2 is now equal to what? Is now equal to what? V1 is what? 2% weight in volume. 2% weight in volume times V2. Sorry, this is too. Let me bring it down here. So we have that C2 is equal to what? C2 is equal to what? C1 is, which is 2% weight in volume, times V1. V1 is what? 100 ml over V2. V2 is what? 1000 ml. So ml will cancel ml. This 20 will cancel this 20. So we have 2% weight in volume divided by 10, which is what? 0.2% what? Weight in volume. So the concentration of the diluted solution is what? Percentage strength is what? 0.2% weight in volume. 0.2% weight in volume. Now the next question says we should find the what? The ratio strength. The ratio strength. Now, to find ratio strength, remember, let me clean the board. To find the ratio strength, let me clean here. To find the ratio strength, remember that 0.2% weight in volume is certain as saying 0.2 gram. 0.2 gram in what? 100 ml solution. That's mean of the 0.2% weight in volume. Now, Remember, for us to move this to ratio strength, we'll try to make sure that this first term here becomes 1. That means we'll find an equivalent fraction of this, because this is sitting as saying 0.2 gram in what? 100 mil. So we need to find the equivalent of this such that the numerator is 1. That means we divide both the numerator and the denominator by what? 0.2. So if we divide it, we have 0.2 gram divided by 0.2 is 1 gram. In 100 mil divided by 0.2 is certain as saying 100 mil divided by 2 over 10, which is certain as saying 100 mil times 10 divided by 2, which is 10 over 2 is 5, times 100 mil is 500 mil. So this is 1 gram in what? 500 mil. So we have moved it in this form. It's now 1 gram in what? 500 mil. Remember our ratio strength. This will now become something like this. This will now become 1. This will now become 1 in 500. 1 in what? 500. This gram will turn to what? Weight. Why this mean will turn to what? Volume. This is the ratio strength. 1 in 500 weight per volume. This is the ratio strength of the diluted what? Products. Please, if you have any question, feel free to call me. Call the lines, any of the lines on the board. Please call. If I take any step you don't understand, please feel free to call. So I can explain. All right. So now let's go to the next question. Next question says we should find the amount strength. We should find the what? The amount strength. We should find the what? The amount strength. Now let's go. Remember that this is already this is already from what we got here. From what we got here is already 1 gram in what? 500 mil. It's already what? 1 gram in what? 500 mil. So we simply divide through 1 gram over what? 500 mil. So if we divide through 1 divided by 5 alone is what? 0.2. This 0 will make it 0.02. This last will make it 0.002. So we have what? 0.002 gram per what? Mil. This is the amount concentration. 0.002. Because 1 divided by 5 is 0.2. 0.02. 0.002. So this is 0.002 gram per mil. But this is the conventional agreement on this. But because of this 0.00, you may want to move it, change this gram to milligram. No problem. So if you work like that, we have here becomes what? 1 gram becomes 1,000 milligram over what? 500 mil. If you divide 2, we have 2 milligram per what? Mil. 2 milligram per mil. All right. I'll give another 2 minutes. If you have any question, please feel free to call so I can explain. Okay, let's move to the next question. Okay. Okay, let's look at this question. The question says, what volume of a 1 in 400 volume in volume solution is needed to produce 5 liter of a 1 in 2000 volume in volume solution? All right, solution. Solution. Okay, let's look at this question again. What volume of a 1 Hello? Okay. Excuse me, please. I'll be right back. Okay, so let's go over the question again. What volume of a 1 in 400 volume in volume solution is needed to produce 5 liter of a 1 in 2000 volume in volume solution? Now, to solve this question, to make it very easy, we still go back to the dilution formula. C1 V1 is equal to C2 V2. So we'll say C1 V1 is equal to what? C2 V2. C1 V1 is equal to what? C2 V2. Now, from this question, the stock solution has concentration of what? 1 in 400 volume in volume, which is ratio strength. But no volume was given. The volume of the concentrated solution or the what is it called, or the stock solution that was used was not indicated. But it was diluted to another strength, which is 1 in 2000 volume in volume. And the volume of that new concentration is what? New solution is what? I mean, the diluted solution is what? 5 liters. So we have our V2 to be 5 liters, our C2 to be what? 1 in 2000 volume what? In volume. But we don't know. We have 1 in 400 volume to volume, but you don't know the what? The volume. Now, for us to solve this, remember also that volume in volume means that both the ingredient and the final products, they are both what? Liquid. That means liquid was poured inside another vehicle, which is also liquid, to prepare a solution. Example, in case of water and alcohol, something like that. So for us to be able to solve this thing, we need to move this ratio strength, move it to what? Percentage strength. To make it easier, let's move this to percentage strength. I'll move this one to percentage strength too. So let's go. So if we move this one, if we move 1 in 400 volume to percentage strength, we have something that is, this 1 in 400 volume means there is 1 ml in what? 400 ml of the entire what? Solution. So to move it to percentage strength, we now find how many ml will be in 100 ml. So we call it X. X will be in what? 100 ml. So X is now equal to what? 1 ml times what? 100 ml over what? 400 ml. Ml will cancel ml. This will cancel this. So we have 1 over 4 ml, which is what? 0.25 ml. So there will be 0.25 ml in what? 100 ml. So if we move this to percentage, this becomes what? 0.25% volume. This may be turned to volume. This one will turn to volume. Volume in what? Volume. So this is the what? Percentage strength. This is what? C1. So our C1 is what? C1 is what? X is our C1. So our C1 is what? 0.25% volume in volume. Now the next thing we look at is the C2. This, okay, yes, C2. C2 is 1 in 2000 volume in volume. So if you have 1 in 2000 volume in volume, simply means 1 ml in 2000 ml. So how many will be in 100 ml? We call it X. So this X is our what? You can say X2 or you can say, you can also use C2. It's okay, no problem. Any of them is okay. So how many will be in what? 100 ml. So if you multiply, we have as X2 is now equal to what? 1 ml times what? 100 ml over what? 2000 ml. Ml will cancel ml. This 2 0 will cancel this 2 0. So we have 1 ml over 1 over 20 ml. Remember that 1 over 2 ml. Okay, sorry, 1 over 20 ml is, okay, 1 over 2 ml is 0.5. So 1 over 20 ml is 0.05 ml. So here is what? 0.05 ml in what? 100 ml. So if we have 1 ml in 2000 ml, therefore 0.05 ml will be in what? 100 ml. So if that is the case, this implies that the percentage strength is what? 0.05 percentage volume in what? Volume. 0.05% volume in volume. This is C2. C2 is X2. So we have succeeded in converting C ratio strength to what? Percentage strength. Now, we have gotten our C1, C2. Then our V1, we don't know V1. We are looking for what? V1. Then our V2 is 5 liter. Our V2 is 5 liter. Our V2 is what? 5 liter. If we want, we can distribute it in another 5 liter and do our thing. If you want, we can still move it to what? to what? Mil. Let me leave it at 5 liter for now and see how it goes. It's 5 what? Liter. So let's go. Let's go. So if we now do this, we have something like this. We are looking for V1. So let's come here. So our V1 from this formula is now equal to what? C2 V2 over what? C1, which is C2 is what? 0.05. 0.05% volume in volume times V2 is what? 5 liter, which is 5 liter. All over C1 is what? 0.25. 0.25% volume in volume. %0.05% volume in volume times 5 liter over 0.25% volume in volume. Percent volume in volume, we cancel percent volume in volume. We are left with 0.05 times 5 liter over 0.025. We have something like this. 0.05 times 5 divided by what? 0.25. So we have 1 liter. So we have what? 1 liter. So V1 is actually what? Let me come up here. V1 is actually what? If we divide through, V1 is what? 1 liter. V1 is what? 1 liter. So this is the volume of this strength that was diluted to 5 liter to produce 1 in 2000 volume in volume. I will give us like 1 minute, 2 minutes. If you have any questions, feel free to call. Call the lines, call the numbers on the board. If there's any step I took here that you are struggling to understand, feel free to call and I will take care of that. Okay, in the absence of any question, we'll move over to the next question. Okay. The next question says, what volume of a 40% weight in volume solution needs to be used to produce 500 ml of a 5% volume in volume solution? All right, let's look at the question again. Solution. What volume of a 40% volume in volume solution needs to be used to produce 500 ml of a 5% volume in volume solution? The stock solution here has a concentration of 40% volume in volume, but we don't know the volume we need to take and dilute to produce 500 ml that will have a concentration of 5% volume in volume. We don't know. Then another point there is that by virtue of percentage being in volume, it's clear that this is the case of liquid and what? Liquid. We don't know the volume of the stock solution. We call it V1, but we know the concentration, which is C1. Then when diluted, it will produce 500 ml. That is, the V2 is 500 ml. And the second concentration, C2 of the diluted solution is what? 5% volume in volume. So with that, we can also go back to our dilution formula, which says that what? C1 V1 is equal to what? C2 V2. C1 V1 is equal to what? C2 V2. Here now, our C1 is 40% volume in volume. So C1, we know C1. C1 is what? 40% volume in what? Volume. We know V1. So we don't know V1. We know C2 as what? 5% volume in volume. We know V2 as what? 500 ml. So let's calculate the V1. So from this formula, making V1 the subject of the formula, V1 is equal to what? C2 V2 over what? Over what? C1. So let's substitute. C2 is what? 5%. So we have 5% volume in volume times V2 is what? 500 ml. We have 500 ml all over C1, which is what? 40% with volume in volume. Sorry. So percent volume in volume will cancel percent volume in volume. So we have 5 times 500 over what? 4. This will divide this. So if we have 5 times 50. So if 4 divide 50, we have 12.5. Because 2 divide 50 is 25. 2 again, 12.5. So here is 12.5. And if we 12.5 times 5, 12 alone times 5 is 60. So 0.5 times 5 is 2.5. So the answer is 62.5 ml. So what this means is that if you take 62.5 ml, if you take the 62.5 ml of these stocks, of this 40% volume in volume solution, and they dilute it up to 500 ml solution using the appropriate vehicle to produce 500 ml solution, the concentration of that solution will be what? 5% volume in volume. Will be what? 5% volume in volume. So the answer is what? 62.5 ml. 62.5 ml. This one is straightforward. But if you have any question, I'll give 1 minute. Please call, so I can attend to it. ask your question, please call the line, call numbers, any of the numbers on the board. Okay, in the absence of any question, let's go over to the next question. Okay. Okay, the question says, to what volume must 250 ml of a 25% weight in volume solution be diluted to produce a 10% weight in volume solution? All right, solution. Now let's look at this question again. To what volume must 250 ml of a 25% weight in volume solution be diluted? So the stock solution is what? The one that has percentage strength of 25% weight in volume. And the volume of that stock solution is what? 250 ml. So we need to dilute for us to produce another solution that has lesser concentration. We have to do what? Dilute it. And we know the concentration to which we want to dilute it to, which is 10% volume, from 25% volume in volume to 10%, from 25% weight in volume to 10% weight in volume. We know where we're taking it to, but we don't know the volume to which we are diluting it to. That's what we are looking for. So we are looking for our V2 here. Judging by our dilution formula, we are looking for what? V2. So going back to our formula again, C1V1 is equal to what? C2V2. From this question, we know our C1. Our C1 is what? 25% weight in what? Volume. Our V1 is what? 250 ml. Then our C2 is what? 10% weight in volume. Our V2 is what we're looking for. We don't know. We're looking for what? V2. We don't know. Now, what do we now do? That means we need to make V2 the subject of the formula. So making V2 the subject of the formula, we have V2. We have that V2 is now equal to what? C1 V1 over what? C2. Lest I forget, please remember that here we have weight in volume, unlike others where we have weight in volume, weight in weight. Here is weight in volume. What it means is that the ingredient that is dissolved in the vehicle, the ingredient is solid, while the vehicle is liquid, and the consistency of the product will also be what? Liquid. That's the meaning of this weight in what? Volume. So let's go back to what I'm looking for. So V2, our C1 here is what? 25% weight in volume. So we have C1 is what? 25% weight in what? Volume. Times V1. Our V1 is what? 250 mil divided by our C2, which is 10% weight in volume. Percent weight in volume will cancel percent weight in volume. This 10 here will divide, we cancel this 0 here. So that means this 0 here will cancel this 0 here. We are left with what? 25 times 25 mil, which is 600 and what? 25 mil. So the final volume is 625 mil. What it means is that if you take 250 ml of a 25% weight in volume solution and dilute it to 625 ml, you will produce a solution with percentage concentration of what? 10% weight in volume. That's the meaning. So the answer is what? 625 ml. As usual, I'll give 1 minute. If you have any question, please ask. Under this 1 minute. So we move ahead. Okay, so let's move to the next question. Okay. The question says, what weight of ingredient is required to produce 1000 ml of a solution such that when 2.5 ml of it is diluted to 50 ml with water, it gives a 0.25% weight in volume solution. Now, let's solve this question. Solution. Let's solve this question. Now, they're not asking the weight of the ingredient. Now, we don't know the weight of the ingredient. Its particular weight was just dissolved in suitable solvent, water, precisely, and they make it up to what? 1,000 mil. This will serve as the stock solution. So from this stock solution, 2.5 mil was taken and diluted to 50 mil with water to produce a concentration of what? 0.25% weight in volume. The question is now to calculate the weight of that ingredient. If we can calculate this by moving from the beginning of the making of the stock solution down, but it will be a long process. It will make us to call the weight W or X or anything, then start calculating. It will take us long way to arrive at the answer. The shortest means is to solve from back, from the end to the beginning, by noting that we already have V2 here and C2 here, and we already have V1. We don't know C1. Please don't allow this volume here to confuse you with this volume here. Let me explain. A stock solution was produced. A specific amount of the ingredient was dissolved to make a stock solution of 1,000 ml that will have a particular concentration. Provided nothing was added or removed from it. If you take 50 ml from that stock solution, it will still contain the same. It will still give you the same concentration. And also, provided that you did not add the ingredient again, it also have the same the amount of the ingredient. The amount of the ingredient will be the same thing, especially when you dilute it. Now, having that at the back of our mind, let us now solve this question. So this is the V1, not this one. 2.5 mil is the V1, not 1,000 mil, because the solution was made, and from there 2.5 mil was taken. And is that 2.5 mil that was diluted, not 1,000 mil? That's the point I'm trying to make. Now, remember our dilution formula. That C1 V1 is equal to what? C2 V2. So solving from the end to the beginning, we have our C2 to be what? From this question, C2 is 0.25%. Because that is the what? The new concentration that was formed, that was when this thing was diluted. Now, V2 is what? The volume of what was produced is what? 50 ml. C1, we don't know C1. We don't know the concentration of the stock solution, because we don't know the amount of ingredient that was dissolved, that was used to make the stock solution. So we don't know the concentration of the stock solution. But we know C2. Okay, we see C2 here already. Then V1, we know V1. Because the V1 is 2.5 mil. Again, V1 is 2.5 mil, if not 1,000 mil. Because the whole 1,000 mil was not used. Had it been, as we saw in the previous questions we solved, where the whole volume of the stock solution was used, then that means the 1,000 mil will be V1. In that case, there will be no need talking about 2.5 mil. But since 2.5 mil was taken, then it becomes what? V1. So we are looking for what? C1. So making C1 the subject of the formula, C1 is now equal to what? C2 V2 by what? V1. Which is, C2 here is what? 0.25% weight in volume times V2 is what? 50 mil. All over V1 is what? 2.5 mil. 2.5 mil. So let's not waste our time. Let's just punch it directly and take it off from there. So we have 0.25 times 50 divided by 2.5 is what? 5 mil. It's what? 5, not 5 mil, sorry, because mil we cancel mil. 5% volume, weight in volume. 5% weight in volume. So the concentration of the stock of this stock solution is 2.5%, sorry, 5% weight in volume. Remember again, from that stock solution, 2.5 mil was taken. Irrespective of the volume of the stock solution that they will take, it will have the same concentration, because it is the same stock solution that was taken. Even if it took 500 mil, they will have the same concentration, this same 5% weight in volume. So that means the C2 now, C1 now is concentration of this stock what? Solution. So don't allow this 2.5 mil that was used to confuse you, but it will have the same concentration. Now, having agreed that the concentration of stock solution is what? 2.5% weight in volume. Let us now take it up and use it and set a proportion with this volume and find the amount of ingredient that was dissolved. So let's go. So the next step to take now is to find the amount of ingredient that was dissolved. Let's open up this 5% weight in volume. This 5% weight in volume means 5 grams of this ingredient in 100 ml. That's what it means. It means 5 grams of this ingredient in 100 ml. So it means 5 grams of the ingredient in question in what? 100 ml. That means of 5% weight in volume. Weight, we take weight back to gram and take volume back to ml. So we have 5 grams in 100 ml. Now, but we don't know if there are 5 grams in 100 ml, how many of that ingredient will be in 1,000 ml of the stock solution. That's how to calculate the amount of ingredient that was dissolved to make up that 1,000 ml. So we don't know, we call it what? X. X in what? 1,000 ml. So we find this X. So X is now equal to what? 5 grams times what? 1,000 ml over what? 100 ml. So ml will cancel ml. This 20 will cancel 20. We have 5 grams times 10, which is what? 50 grams. So actually, 50 grams of the ingredient was dissolved in small amount of water. I'll make it up to what? 1,000 ml to form the stock solution. From this stock solution, 2.5 ml was taken. And that 2.5 ml will have the same concentration with the stock solution. So from that 2.5 ml was taken and diluted by making it up to what? 50 ml. And this final 50 ml has concentration of what? 0.25% weight in volume. So that's the answer to the question, 50 grams of the what? Ingredients. So I don't know if there's any question, please feel free to call this line. We've come to the end of today's lecture, but I want to give like 1 minute to know if there's any place you don't understand, you find difficult to understand, so I can explain. 1 minute. After 1 minute, we end the lectures. The numbers are on the screen, on the board. Okay, our 1 minute has elapsed. So I want to thank you for today's class. And if you have any other question, this video will still be on YouTube. Just go to the live section, click on the live, you see this lecture. If you have any question, then feel free to chat me up on WhatsApp via this line. You can drop a comment on the comment section. Feel free to do that. So thank you very much once more. And please, let's not forget, I organize academic competition every Saturday, 7 a.m. to 7:10 a.m. Different subjects from arts, sciences, commercial courses, even medical courses. And the registration fee is free of charge, is zero. There's no fee attached to it. And our prize is to be won. This academic competition will help, is geared. The aim is to help build our youth academically, to motivate our youth to pursue academic excellence. The title of the battle is, the competition is Academic Battle with Pharmaceutical, the School Board. Please subscribe to my YouTube channel. My YouTube channel name is Pharmaceutical, the School Boy, and click on the notification bell for updates on live lectures like this. The academic competition that is coming up this Saturday is Government Battle 2.0 with Pharmaceutical, the School Boy. Registration is still on. Chat me up on WhatsApp so I can send you the link for the registration. You can also check out in the post section of my YouTube channel. You see the flyer and the registration link. Thank you very much once more. God bless you. See you next time.